My name is Arunesh Mathur, and I'm excited to talk to you about my dissertation. Over the past few years, we have seen a rising tide of online manipulation where powerful actors on the web use a variety of different tactics to negatively influence users and subvert their decision-making process. While the phenomena of manipulation itself isn't new, the architecture of the web has allowed a variety of manipulative tactics to flourish and thus harm users. As a result, this has required research that examines these practices in more detail. In my dissertation, I asked three research questions. What are the common manipulative practices on the web that manifest in the user interface? How can we identify and measure these user interfaces at scale? And what can we do to mitigate the spread of these user interfaces on the web? I present case studies that characterize and quantify three manipulative user interfaces. My research shows that it is possible to characterize and quantify these interfaces because they share common traits. As a result, we can use web automation and machine learning methods to identify them at scale. In the first study, I examined the prevalence of undisclosed online endorsements. So what is an endorsement? Here is one example where a YouTuber by the name of Gohan the Husky is promoting a vacuum cleaner and encouraging his audience to purchase the cleaner through a link in the description of the video. This is an example of an affiliate link, a link that earns Gohan money when people use it to buy the advertised product. This, of course, is a perfectly lawful practice, but various government regulations require content creators like Gohan to disclose their relationship with advertisers to their audience so that the audience is not misled into believing that they are watching non-advertising content. To quantify how often content creators like Gohan disclose, I assembled a dataset of nearly 500,000 YouTube videos and 2 million Pinterest pins. I then resolved all the URLs present in these videos and pins. And then I used unsupervised machine learning methods to cluster the video and pin descriptions, and then I extracted the clusters that corresponded to endorsement disclosures. I found that nearly 90% of all affiliate marketing endorsements are not disclosed by content creators to their audience, thus violating the FTC's guidelines and other regulations around the world. The most prevalent type of disclosure is also explicitly discouraged by the FTC and least understood by users. In the second study, I examined the prevalence of so-called dark pattern user interfaces in shopping websites. Dark patterns are user interfaces that benefit an online service by influencing users into making decisions that they would otherwise not make. There exist a variety of dark pattern interfaces that have been characterized and defined in various taxonomies that have been created by researchers. In this study, I examined how often dark patterns appeared in 11,000 of the most popular shopping websites worldwide. To identify dark patterns at scale, I developed a shopping bot that visited websites and extracted pieces of text, amongst other information. I then used unsupervised machine learning methods to cluster this content and then extracted all those clusters that corresponded to dark patterns. I discovered nearly 1,800 dark patterns on 1,200 shopping websites. These together represent 15 types and 7 categories of dark patterns. Some of the dark patterns I discovered included fake countdown timers and interfaces called trick questions that confuse users into giving up their privacy. In the third study, I examined the prevalence of dark patterns and clickbait in political campaign emails. Emails are an important part of how political candidates running for office, as well as political organizations, raise money here in the United States. But at the same time, there has been a spate of reporting describing how these emails often contain manipulative and deceptive user interfaces. I quantified the prevalence of these interfaces in emails from about 20,000 candidates running for office and organizations active in the 2020 election cycle. I developed a bot that automatically signed up for emails from these candidates as well as organizations, and I gathered a dataset of nearly 100,000 political emails. I developed machine learning classifiers to automatically detect and quantify manipulative user interfaces in these emails. I found that nearly 40% of all the emails from the median sender contained at least one manipulative interface. Some senders largely avoided these tactics, while others used them very often. Some of the dark patterns I discovered in campaign emails included those that obscured the sender's name to users, thus creating a sense of curiosity, as well as clickbait techniques that create a false sense of urgency to drive users to donate money. To conclude, my dissertation makes the following contributions. It presents automated data collection and analysis techniques to measure manipulative user interfaces at scale. It contributes datasets recording every instance of these manipulative user interfaces, and it shows that the scale of measurement enables new insights into what these user interfaces look like. I have communicated the findings of my research to various policymakers, such as the Federal Trade Commission, the Advertising Standards Agency, and the Norwegian Consumer Council. These agencies have since released reports and guidelines to rein in on the user interfaces that I describe in my dissertation. I've also released code and data from my research so that other researchers can build upon the research that I present in here. Please feel free to reach out to me if you are interested in learning more about these studies in my dissertation.